So this is problem 1 from chapter 3. It's the month's total pay. So essentially we have a for loop here, and this is 2 to the x function, and our I iterations is wired into x. We have 29 wired into our n, which means the for loop will run 29 times. So I will go to 29. We pipe this out into an sum, add all the elements, and then that is wired into here, into this indicator to show the total number of pennies, and then down here that sum is divided by 100 to give the total amount in dollars. And it's 29 because when you start, I equals 0 is the first value and 2 to the 0 is 1, so it kind of checks out that having I equals 0 for the first one works. And here are the indicators, and we'll run this. And you see you get a lot of pennies, and in dollars, it's still a lot, but that's how many you get for the month's pay. Going to go... Here is the finite geometric series. Here's the whole thing. So essentially, we have another for loop here, and we have a numeric control going into it, so we can determine the number for n. We have an x value here, which is also a control value. It wires into the for loop into this x to the y function, and our I is our exponent value here, so it'll keep going up, determining on what we set n to be. And down here, the x goes into 1 minus x, and then it takes the reciprocal, which is 1 over 1 minus x, and this is our y infinity value. So back up here with the x to the y, since it's a geometric series, it's going to add all the values together. And right here we have an indicator which tells us what the yn value is. And then all this here is essentially telling us the percent deviation from y infinity. So you can see we take the yn minus the y infinity, and then we divide it by that, and we times it by 100, and take the absolute value. And I already have some numbers put in, so we can run this continuously. And as you can see, as you change n, numbers go up, and as you control x, numbers go up, which makes sense because it's a sum, so the more input, the more output, you know? But yeah, this was problem 1 and 2 from chapter 3.